In this video, guys, let's take a look at the hardware, the PLC hardware itself. I mean, there's nothing special about ABB's PLC I want to discuss here, but I would like to point out a few points which are common to any PLC you come across, and those are the things that would come in between if you try to write your own Modbus drivers. So it has to be ABB's 07KR51, I believe. Well. Yeah, this is the hardware. This is the CPU. This is the total hardware. This is how the CPU looks like. Well, I'm not trying to read all the point, but you should take a look. Yeah, this is a CPU, and this XI means digital input, XO is digital output, and I don't know how the analog IOs are named, not quite sure yet. I gotta be saying that number on the module I have. What power cutoff drops battery? Usually they have batteries for real-time clock, which is not needed in my case, and EPROMs don't need batteries. So flash and EPROMs don't need batteries. Only real-time clock needs. So technical spec, not interested. This is common. I hope you know all that. How to open it. Ooh, this is the reset button, I believe, and this is what? This is run status. This is error status. LEDs. What is that? Looks like it's a switch. Probably these switches are for setting RS485, hardware numbers. If you're using your CPU as a uh, slave device, I mean, if it's a part of RS485 or RS422 network, and your CPU seems to be your CPU is a slave, then you are be setting the number from there. General setup rules, what are rules? These are common things. Least bother. Oops. Yeah. So CPU has some inputs. 1, 2, 3, 4, 5, 7, 8. This is what is that? Okay, this is the power supply area. This is how you connect it. And this is what? This is some pot. Variable resistance. Analog inputs. IWs. Power run error. Good. PKG. What kind of function is that? Ooh, not interested. Not interested. Not interested. This is how you wire it. I hope you know that. Why is this diode here? So that they don't get reverse voltages. Okay. Not interested. These are things. Intelligent Modbus coupler. Okay, so this is the Modbus coupler I have. Okay, so this is the programming terminal. If you have seen my first video, I am not using it. I use it when I write my FBDs and I want to burn inside the flash up here. This is a Modbus coupler. This uses RS232. You can also use it as a SCADA port. I've used it many times. And then you have up here you have a 485 port, which I am currently using. This one over here. What else? Yeah, this is the architecture. From a PC master, Modbus master, this is the daisy chain you have. Over the daisy chain you have these devices. CS31 bus. Oh, ooh. This bus over here is SPI. I don't know what this bus is. Probably they have given SPI a fancy name. Okay. Well, coupler, not interested. Looks like this is for setting hardware numbers, hardware slave address. These are the error TXRX means receive, transmit ports. Okay. This is mini DIN 9, mini DIN 8. This is mini DIN 8 male connector, I would say. This is ground, this is CTS clear to send, this is RX receiving, this is 5 volt positive, this is TX transmitting, this is RTS means ready to send, means these two put together they are hardware flow control, and these are receive and transmit, and then you have power and ground. Good. What else do they have? They have RS232, 485. Nothing special. They are saying this Modbus network established, wire resistance. Don't worry. What is that? Oh, these are the baud rates they support. Well, when I do my device, I usually test it with. Actually, these boards have a relation with the cable length. So 9600, which I have used over RS485, so it should be about 1200 meters. 115-200, this is very aggressive baud rate. You can so 115-200 bits per second is 600 meter, which is very much in range. I remember I've had a device 6 meters away from my master, so 115-200 you can do. Modbus addressing method, I know, I expect that you know for your PLC. I know for mine. I know these values, so I'm not paying much attention to it. But scrolling through these things might help you. What is this? Oh, okay. Analog display. If you on my analog input, if you see the first video, I was trying to read channel 7. So this is the button you press, and then it kind of toggles through 0 to 7 ports. So I have my PT100 at port number 7, which is, if you count from 1, it's port 8. So that was the value it was showing. What is that? Analog extension. This is analog output, and this is SPI bus. What else do we have? Currents, powers, 4 to 20 mil. Accessories. Well, this is a programming cable. Yeah, I never bought a programming cable ever. I always make it myself. And this is a mini D9. So this is the PC side. So receive, so transmit goes to receive. And since it's a straight connection, it has to be crossed. So transmit goes to receive, and from receive here goes to transmit here. Ground is kept common, and then got a shield common earthing point, and then hardware flow control, CTS and RTS, they are shorted out. That means flow control will be done by software, and there will not be any hardware flow control. And DTR and DSR was the old way of doing flow control by telephones, some 20 30 years back, I believe. So nobody uses it anymore, so you short it out, and they don't care. kind of connections.